Theoretically, if you could take 22 carbons, 28 hydrogens, 2 nitrogens, and an oxygen and smash them together to create a structure that looked like this, well, you would have created N-phenyl-1-2-phenyl piperidine-4-ol propanamide, perhaps better known by its common name free of chemistry jargon, fentanyl. Since its creation and introduction in the late 1950s, fentanyl has been used in healthcare applications as a potent solution to severe pain. In that aspect, its creation and use has been a success, providing relief to thousands suffering from surgical, chronic, and disease-related pain. On the other hand, fentanyl is inexpensive to manufacture and extremely potent, leading to widespread illicit use. It has become infamous worldwide as a deadly substance, a major contributor to drug overdoses, and a common catalyst for opioid addiction. In today's video, I aim to analyze fentanyl at large from 3 perspectives. First, and most thoroughly, through the lens of organic and biochemistry. Fentanyl's structure, components, and properties, how those properties affect the drug's interaction in the body, and how fentanyl and other opioids fundamentally function to reduce pain. Second, the societal impacts that fentanyl creates. Why is fentanyl addictive, and what factors contribute to it being such a dangerous drug? And finally, the third, how does an understanding of fentanyl influence my future career as a pharmacist or medicinal chemist? Fentanyl is an opioid, a classification given due to its properties mimicking those of the natural substances found within the opium poppy plant. Now, mimicking is a key word there, as fentanyl is a synthetic, not derived directly from opium, the sap of the poppy plant, unlike other common opioids, morphine and codeine. Fentanyl was first synthesized by a team of scientists led by Dr. Paul Janssen in 1959 and was introduced for widespread usage in 1960. Fentanyl contains 2 aromatic phenyl groups, here and here, a tertiary heterocyclic amine, namely piperidine, found here, an amide group right there, which is made up of this carbonyl group and that tertiary amine. Now toss in a few carbons here and there and Bob's your uncle. Fentanyl! It touts a chemical formula of C22H28N2O and has a molar mass of 336.5 grams per mole. Fentanyl molecules are overall nonpolar, making them lipophilic, which is defined as the ability to dissolve, be dissolved in, or absorb lipids. Now that will be important later, so don't forget that. In order to understand how fentanyl works within the human body, a quick nervous system refresher is in order. The human nervous system is made up of a whole bunch of nerve cells called neurons. These neurons create cell bodies that vaguely resemble Patrick Star, called axons. Axons have feely, finger-like dendrites on one end and axon terminals on the other. Now bundle millions of axons together and run them through our bodies and you've created the human nervous system. Axons send messages to one another by releasing chemical neurotransmitters like dopamine and serotonin from the axon terminal through the synapse, a space between axons' respective ends, to the dendrites of an adjacent axon. This incredibly important process happens everywhere in your body all the time. Muscle contraction, thoughts, pain, and pleasure, all for the purpose of keeping us alive and thriving. So suppose you got smacked by a tree.
Woo! Bananas are an excellent source of potassium!
Axons in your now tender cheek would pick up a harmful signal and send a warning to your brain of a hazard to your face. Glutamate, a neurotransmitter that says ouch, is released from axons into the synapses and you feel pain. Okay, then how does fentanyl, an opioid painkiller, actually reduce pain? On both the axon terminal and the dendrites are opioid receptors, placed there as a way for our body to interact with endorphins like adrenaline. As the name suggests, opioids also interact with these receptors in our nervous system. When fentanyl molecules enter the body, they naturally bind to opioid receptors in our axons, enacting a chemical process that slows or stops the transmission of pain and anxiety-related neurotransmitters, while simultaneously releasing an elevated amount of dopamine. So to simplify, Fentanyl bottlenecks our ability to feel pain and stress while uncorking a pressurized bottle of pleasure. What's more is that fentanyl is really good at this process, better than most other opioids by a long way. In drug terminology, effective dose 50, or ED50 for short, is the standard for measuring drug potency and is found by analyzing how much of a drug is needed to occupy 50% of the receptors in a subject with that drug molecule. So if we consider a 200-pound man to fill 50% of his opioid receptors with morphine versus fentanyl, you would need 1,360 milligrams of morphine, or, and I'll pause for dramatic effect, 4 milligrams of fentanyl. For perspective, if you pretend that 4 milligrams of fentanyl was equal to 8 ounces of fentanyl, to achieve the same pharmaceutical effect as that amount of fentanyl, you would need to consume, give or take a little, a measly 22 gallons of morphine. I think this pretty well sums it up.
Drugs are so bad!
Fentanyl is potent, no doubt about it, but why is it so famously dangerous? Why is it responsible for the majority of worldwide overdoses and deaths? Remember before when I mentioned that fentanyl was lipophilic? Cells in the human body have membranes that function as barriers, and these membranes are made of fat. Fats are just another word for lipids. If you recall, lipophilic molecules can easily be absorbed by lipids and therefore our cells. Now, functionally what this means is that fentanyl enters our system quickly and efficiently. In addition, its lipophilic nature means it takes much longer to be evacuated from the body. Thus, fentanyl highs begin very fast and last long. Plus, the release of dopamine associated with intaking fentanyl is intense. If you visualize dopamine levels in the brain as a line, a spike in dopamine would elevate these levels drastically. Our bodies would see a rapid increase in dopamine levels and in turn stop producing dopamine. The high wears off, dopamine levels tank to below normal. The human brain associates this increase with fentanyl and the tank that followed to a lack of it. Because of this, powerful addiction begins and this dopamine cycle continues. Also, if you imagine that you had a pill of pure fentanyl equal in size to a 200 milligram ibuprofen tablet, the little round ones, now take that pill, cut it into 100 pieces and ingest a single piece, a 100th of that pill. A dose that size, only 2 milligrams of fentanyl would result in an overdose and kill most people. In addition, fentanyl is most commonly found mixed with other illicit substances like heroin, cocaine, or methamphetamine. And more often than not, doses mixed with fentanyl contain lethal amounts and contribute to a saddening 150 deaths by opioid overdose daily. To conclude, my role as one integrated in the world of pharmaceuticals is drastically important. Above all, I see proper dispensal and understanding of drugs, particularly ones like fentanyl, as absolutely crucial. A mistake in prescribed dosage or ignorance to the effects could result in a loss of life. A goal that I have is to help those I serve understand the effects of drugs for both good and bad, because greater education on their function and use could potentially save a life. Thanks for watching, and don't do drugs.